Welcome. This video will illustrate creating QQ plots and other plots using proc univariate. This procedure can also provide a very detailed numerical summary of a quantitative variable, but here we wish to see only its graphical output. In order to follow along, you will need the SAS dataset pulse_step 1 after labeling the variables. I have opened SAS and opened the SAS program topic 5c.sas. We will start with printing the dataset, followed by looking at the variable list from proc contents. Notice that the raw data are numbers for our categorical variables. We cover how to translate these codes in our output in other tutorials. However, that won't matter for this tutorial, as we will be focusing on our quantitative variables: height, weight, age, pulse 1, and pulse 2. To create quantile plots, commonly abbreviated QQ plots, we use proc univariate, as proc sgplot does not offer this plot option. Note that the QQ does not stand for the variable types, as in our case QQ, where we are looking at two quantitative variables. The Q's in QQ plot stand for quantile, which is the method of comparison of our one quantitative variable to the theoretical distribution of interest, in our case the normal distribution. Although they will look like scatter plots, there is only one variable from our sample represented in the graph. We begin with proc univariate and select our data as usual. We add the no print option since we only want to see the graphs in our output. If you wish to see the full default output, remove that option. If you wish to see everything univariate can do, replace it with the all option. We end our first line with a semicolon. Then we have a var statement to specify the variables we want to analyze. Similar to proc means, if we do not put a var statement, we will obtain results for all of the variables in our dataset. We definitely don't want these kind of results for our categorical variables. In this case, we begin with one variable, height. Next, we illustrate three graphs designed to compare to a normal distribution. We always request the first, the QQ plot, but the others are probability plots and probability plots. The more all three of these follow a straight line, the more normal. The last will always match at the beginning and end, so the deviations to consider are those in the middle of the plot. A perfectly normal distribution would follow the line perfectly, but that is not expected in real data unless the sample size is extremely large and the population is normally distributed. Then we request the histogram as well, first with the default settings, then with the normal curve and kernel overlays. The idea is the same as sgplot, but the code is different. The no print option here will suppress a table of information that displays about the normal estimation process. If you wish to see that output, remove the no print option. Here are the plots from that code. We can add all of the variables of interest to the var statement. Here I request only the QQ plot and one histogram for each of the variables. We have the same results mentioned for the histograms in the previous tutorial. In the case of height, the variable seems fairly normally distributed with only minor differences between the red kernel curve and the blue normal curve. The only difference in the histogram and the one from sgplot is some minor formatting differences, including the added text which relates to the estimation of the overlay curves. For the QQ plot, notice the dots are generally randomly bouncing around the line and staying very close to it, except the first and last observations. This confirms that the variable is close to normally distributed based upon the sample. For the remaining variables, weight is mildly skewed right, but clearly so. In the QQ plot, we see this as an upward curve in SAS output. Age is highly skewed right, again an upward curve in our QQ plot. Pulse 1 is basically symmetric with one very large outlier. The QQ plot clearly shows this one observation as unusual, and the rest of the data are reasonably normal if that observation was ignored. Potentially, it's an error from self-collected pulse readings. For pulse 2, the histogram is bimodal and skewed right, with the left cluster being more narrow and the right cluster being more spread out. Since about half of the students ran and half sat, this isn't surprising. The QQ plot shows an S-shaped pattern, which overall has an upward curve. There are numerous S-shaped patterns, so be sure to look at both the histogram and QQ plot to determine the whole picture. Really, for each quantitative variable, you would like to see all three plots, a histogram, a box plot, and a QQ plot, to develop a complete picture of the distribution of the values of the variable in your sample. That's it for creating QQ plots and histograms using proc univariate. Thanks for watching.